Hi everyone, I'm going to start a new series of videos where I'll explore how to design and implement scalable, secure, and robust integration solutions for modern cloud and hybrid environments. Whether you're moving data between data warehouses and CRM systems, integrating software as a service applications, or building event-driven architectures, this series will provide you with the patterns, tools, and best practices you need to succeed. Please use the comments down below to let me know if you're interested in this and which particular scenarios and patterns you would like to hear about. In this video, we'll explore a generic cloud integration pattern that you can use to securely and efficiently move data between systems. To make this practical, we'll use an example of integrating a data warehouse like Snowflake with a CRM system like Microsoft Dynamics 365. Data will be stored in Microsoft Dataverse. Here's what I'll cover. I'll introduce the integration pattern and why it's useful for modern data pipelines. I'll dive into the key requirements for building a secure, scalable, and robust integration. I'll walk through the high-level architecture, breaking down each component and how they work together. I'll also explain how to handle errors and monitor the pipeline to ensure reliability. And finally, I'll wrap up with best practices and key takeaways to help you implement this pattern in your own projects. By the end of this video, you'll have understanding of how to design and implement this integration pattern, whether you are working with Snowflake and Microsoft Dynamics 365 or other systems. Let's get started. Let's start by understanding what this integration pattern is all about. In today's data-driven world, businesses often need to move data between systems like data warehouses and CRM or ERP platforms. For example, you might have a cloud data warehouse like Snowflake that stores analytical data and a CRM system like Microsoft Dynamics 365 that powers your customer operations. The challenge is moving data between these systems in a way that's secure, scalable, and reliable. That's where this integration pattern comes in. This pattern is designed to sync data periodically, like daily or hourly, from the source system to the target system. Handle large volumes of data efficiently without overwhelming the system. Support absurd operations. Absurd means update or insert, meaning it can update existing records or insert new ones without requiring manual checks. And the last one, provide robust error handling so you can identify and fix issues at the raw level. To make this concrete, we'll use the example of integrating Snowflake, a leading cloud data warehouse, with Microsoft Dynamics 365, a powerful CRM platform. But remember, this pattern is generic and can be applied to other systems like Amazon Redshift, Google BigQuery, Salesforce, or SAP. The key idea is to create a pipeline that's secure, performant, and easy to monitor, whether you're working with Snowflake and Dataverse or any other combination of systems. Let's dive deeper into how this works. Now that we understand the integration pattern, let's talk about the key requirements for building a robust data integration pipeline. When moving data between systems like a data warehouse and a CRM platform, there are a few critical things to keep in mind. Periodic data exports. The source system like Snowflake needs to export data on a regular schedule, such as daily or hourly. This ensures that the target system like Dynamics 365, having Dataverse as a data storage, always has the latest information. Secure and performant data transfers. Data must be transferred securely using encryption and authentication mechanisms. At the same time, the process should be optimized for performance to handle large volumes of data efficiently. Absurd support. The target system should support absurd operations, which is update or insert, meaning it can update existing records or insert new ones without requiring manual checks. This is crucial for maintaining data consistency. Row-level error handling. Not every row of data will process successfully. The pipeline must capture errors at the row level, log them for review, and allow for retrieves without disrupting the entire workflow. Monitoring and alerts. Finally, the pipeline should include monitoring and alerting capabilities so you can track performance, identify issues, and take action when something goes wrong. These requirements ensure that your integration is secure, scalable, and reliable, whether you're working with Snowflake and Dataverse or any other combination of systems. Now that I've covered the key requirements, let's take a look at the high-level architecture for this integration pattern. At its core, the architecture is designed to move data securely and efficiently from source system, like a data warehouse, to a target system like a CRM or ERP platform. Here is how it works. The process starts with the source system, exporting data to cloud storage. This could be a daily export of customer data, sales transactions, or any other data set. The exported data lands in cloud storage, like Azure Blob Storage or Amazon S3. These acts as a staging area where the data is temporarily stored before being processed. Cloud storage platforms often support event triggers like Azure Event Grid or Amazon S3 event notifications. These triggers automatically notify downstream services like Azure Functions or Data Factory when new files are added. This enables real-time or near real-time processing. Next, an integration service like Azure Functions or Azure Data Factory picks up the data from cloud storage. This service handles tasks like file parsing, data transformation, and mapping the data to the target system schema. Finally, the processed data is ingested into the target system like Microsoft Dataverse using its API. This step often involves upsert operations which update existing records or insert new ones as needed. Throughout this process, errors are logged for review and the pipeline is monitored to ensure everything runs smoothly. This architecture is flexible and can be adapted to different systems and cloud platforms. For example, you could replace Snowflake with Redshift or Dataverse with Salesforce, and the overall flow would remain the same. In the next section, we'll dive deeper into each of these steps. Let's keep going. Let's dive into the first step of the integration pipeline, exporting data from the source system. In this pattern, the source system is typically a data warehouse that stores large volumes of analytical data. The goal is to export this data to cloud storage so it can be processed and ingested into the target system. Export mechanism. Most modern data warehouses provide built-in tools for exporting data. For example, Snowflake has copy info command, which allows you to export data directly to cloud storage in formats like CSV or Parquet files. Scheduling. Exports are typically scheduled to run periodically, like once a day or once an hour, depending on your business needs. This ensures that the target system always has the latest data. Security. The data exports must be secure. This means using authentication mechanisms like Azure Service Principal or Shared Access Signature to ensure that only authorized systems can access the data. By exporting data to cloud storage, we create a staging area where the data can be securely stored and processed before being ingested into the target system. In the next section, we'll look at how the data is processed in cloud storage. Let's keep going. Now that we have exported data from the source system, the next step is to store it in cloud storage. This acts as a staging area where the data is temporarily held before being processed and ingested into the target system. Cloud storage like Azure Blob Storage, Amazon S3, or Google Cloud Storage provides a scalable and secure way to store large volumes of data. It's also cost-effective since you only pay for what you use. To keep things organized, exported files are typically stored in a structured folder hierarchy. For example, you might have a folder for each data type and files with exported data per date. This makes it easy to keep the file storage in a maintainable state. Cloud storage event triggering enables automated responses to file operations such as file upload and blob storage. They are used to automate file processing tasks. It's essential for data pipeline automation when new files need to trigger data processing workflows. These triggers automatically notify downstream services like Azure Functions or Data Factory when new files are added and eliminate the need for constant polling, making it cost-effective while enabling near real-time processing of storage changes. Data in cloud storage must be protected. This means using features like private endpoints, role-based access control, and encryption to ensure that only authorized systems and users can access the data. By using cloud storage as a staging area, we create a decoupled and scalable architecture. The source system can export data independently, and the target system can process it at its own pace. In the next section, we'll look at how the data is processed after it lands in cloud storage. Let's keep going. Now that the data is securely stored in cloud storage, the next step is to process it so it can be ingested into the target system. This is where integration services come into play. Integration services like Azure Functions, Azure Data Factory, or Amazon Lambda act as the brain of the operation. They pick up the data from the cloud storage, transform it if needed, and prepare it for the ingestion into the target system. When the new files land in cloud storage, an event trigger like Azure Event Grid notifies the integration service. This ensures that the data is processed as soon as it's available. The integration service reads the file from cloud storage and parses them into a usable format. For example, it might read a CSV file and convert it into a JSON object for easier processing. If needed, the service can also transform the data, like renaming columns, converting data types, or filtering rows. This ensures that the data matches the schema of the target system. Finally, the service maps the processed data to the target system schema. For example, it might map a customer ID field in the source data to a contact ID field in the target system. By using integration services, we create a flexible and scalable processing layer that can handle a wide variety of data formats and transformations. In the next section, we'll look at how the processed data is ingested into the target system. Let's keep going. Now that the data has been processed, the final step is to ingest it into the target system. In our example, the target system is Microsoft Dataverse, on top of which Microsoft Dynamics applications work. But this could also be Salesforce, SAP, or any other CRM ERP platform. The goal here is to load the data efficiently and reliably while supporting absurd operations, meaning we can update existing records or insert new ones as needed. Most modern systems provide bulk API for high-volume data ingestion. For example, Dataverse has a bulk API that allows you to send thousands of records in a single request. This minimizes the overhead of making individual API calls and improves performance. To enable absurd, the target system must have an alternative key defined, like email address for contacts or a product ID for inventory. This key is used to determine whether a record already exists and should be either updated or inserted. By default, bulk APIs process records in a non-transactional mode. This means that if one record fails, the rest of the records are still processed. Failed records are logged for review, so you can fix and retry them later. Here's an example of what a bulk API request might look like for Dataverse. In this example, we are sending 2 records to the Dataverse contacts table. If a record with the email johnexample.com already exists, it will be updated. If not, a new record will be created. If any records fail, for example due to validation error, the API returns detailed error messages. These errors can be logged and retried later, ensuring that no data is lost. By using bulk APIs in non-transactional mode and absurd operations, we create a scalable and reliable ingestion process that can handle large volumes of data efficiently. No integration pipeline is complete without robust error handling and monitoring. After all, things don't always go as planned. Some records might fail due to the validation error, network issues, or other problems. Let's break down how we handle errors and monitor the pipeline to ensure everything runs smoothly. When a record fails, for example because of an invalid email address or a duplicate key, the system logs the error details for review. These logs typically include the failed record, the error message, a timestamp of when the error occurred. Here is an example of what an error log might look like. These logs are stored in a centralized error storage system like Azure Monitor Logs, Azure Table Storage, or database, where they can be reviewed and retried later. For transient errors, like network timeouts, the pipeline can automatically retry the operation with exponential backoff. This means waiting a little longer between each retry to avoid overwhelming of the system. To keep track of the pipeline's health, we use monitoring tools like Azure Monitor or Application Insights in Azure. These tools provide real-time metrics like success, failure rate, latency, detailed log alerts when something goes wrong. For example, you might set up an alert to notify you or your team if more than 5% of records fail in a single batch. Finally, you can use automation tools like Azure Logic Apps or functions to periodically check the error logs and reprocess failed records. This ensures that no data is lost and that the pipeline remains reliable over time. By implementing robust error handling and monitoring, we create a resilient and maintainable integration pipeline that can handle real-world challenges. Before we wrap up, let's go over some best practices to ensure your integration pipeline is secure, scalable, and reliable. These tips will help you avoid common pitfalls and build a solution that stands the test of time. Here are the key best practices. Use efficient file formats. Choose file formats like Apache Parquet or CSV for data experts. These formats are compact, easy to process, and widely supported. Optimize parallelism. Split large data sets into smaller chunks and process them in parallel. This improves performance and reduces the risk of timeouts. Secure your pipeline. Use managed identities, private endpoints, and encryption to protect your data at every step. Never store credentials in plain text. Use tools like Azure Key Vault to store sensitive information like credentials. Leverage bulk APIs. Use bulk APIs for high-volume data ingestion. They are designed for performance and can handle many thousands of records in a single request. Implement robust error handling. Log failed records with detailed error messages and set up retry logic for transient errors. Use automation tools to reprocess failed records periodically. Monitor and alert. Use monitoring tools like Azure Monitor or Application Insights to track pipeline performance and set up alerts for critical issues. Test thoroughly. Test your pipeline with edge cases like invalid data, duplicates, and large data sets to ensure it handles real-world scenarios gracefully. Document and automate. Document your pipeline's design and workflows, and automate as much as possible. This makes it easier to maintain and scale over time. By following these best practices, you'll build a secure, scalable, and reliable integration pipeline that meets your business needs and adapts to future challenges. And that's a wrap. In this video, we explored a generic integration pattern for securely and efficiently moving data between systems using Snowflake and Dataverse as our example. We covered the architecture of the integration pipeline, how to export, process, and ingest data, best practices for error handling, monitoring, and security. Whether you're working with Snowflake and Dataverse or other systems, this pattern provides a scalable and reliable way to integrate your data. If you found this video helpful, please like, share, and subscribe for more tutorials on cloud architecture and data integration. You can also connect with me in the comments to this video down below. I'd love to hear your thoughts and answer any questions you have. Thanks for watching, and I'll see you in the next video. Happy integrating. Goodbye.